Rakuten has been leveraging its large, vast data lake to develop intelligent algorithms and to pool its data in order to develop a coherent AI strategy. Next up, we're going to hear how Rakuten is aiming to both increase revenue, decrease cost, and improve operational efficiency with the use of AI. It's my great pleasure to welcome our next speaker of today, the Chief Product Officer of Rakuten OSS. Please give a big hand to Anshul Bhatt, ladies and gents.
Hello, everyone. Anshul this side. Very good morning, good afternoon, all of you. So I'm going to talk about the pragmatic approach to autonomous network. And I think the word pragmatic here is the key word because what all I'm going to talk about, we have actually implemented many of these aspects into our real network. And with that, let me go to this slide. So basically, why Rakuten is unique compared to most of the other telcos of the world is, and especially Symphony, right? So we do have our own mobile network in Japan, whereby we are actually testing a lot of these AI models and our vision for autonomous network in Japan. And once we see the value, once we see the benefit, we bring these models and these AI use cases in Symphony to offer to our global customer pool. So that's been our AI strategy so far. And I'll give you some examples today on some of the key use cases that we are solving in our endeavor to reach the level 4 autonomy, and what are some of the key aspects to target when it comes to reaching the L4 autonomy. So just to give you some background, by the way, like Rakuten, in our general approach to telco, we are more similar to Tesla compared to any other telco, by the way, in our approach to reach towards this autonomous network, in the sense that if you look at Tesla's journey, let's say as an automobile, and if you compare it with the levels of autonomous networks, right? It all starts with like manual operations, but then there is this level 5 autonomy where the car can drive on its own, the self-driving car. So that has been our approach towards telecom networks too, whereby we have already reached level 3, I would say, in terms of having this conditional automation. And here is where the difficult path starts from level 3 to level 5, where we actually start understanding the intent. We start introducing AI in decision-making especially. And in the subsequent slides, I'm going to talk about how or where are we in our journey towards level 5 and what is our immediate goal and some of the steps that we are taking to at least realize level 4 autonomy by end of this year. And before we go on to these, the pragmatic approach as such, I wanted to spend some time on some of the challenges that we face during our journey and we are seeing in a lot of telcos when it comes to implementation of AI. I think, first of all, before we even start thinking about moving and implementing AI, it's very important to make sure that the data is in the right place. We have a unified data platform as such. Otherwise, it's very difficult to apply AI or even to discover the data. And unless you have no visibility on data, even if you have a lot of data scientists or let's say data teams, unless they have access to data, unless they can make sense out of data, it's really difficult to go towards the next steps. And that is where I think the first challenge lies, to have a unified data platform or to have sense or to be able to make sense around your data. And then again, it's good to have AI models and having machine learning implemented, but unless you have the right UX or interpretation enabled to understand the meaning of data, a lot of machine learning or AI projects fail because of missing UX to actually enable AI into the day-to-day use cases. Your NOC engineers are not going to go to a different platform just to access data or AI. So it's very important to have a UX that is, workable with the existing day-to-day tools that your engineers are using. And then one more important aspect is to have a backlog, or what do you want to do with AI? I mean, there is no point in implementing AI for just the sake of implementation. So it's very important or crucial to have a backlog of what use cases you want to target with AI, and especially to be able to prioritize these use cases in terms of value that they are going to add into your whole journey. And then trust and security, again, very important, especially when it comes to data. How are you able to govern the data? How are you able to, sort of have a process around who is accessing the data and why is very important, especially when we go towards more and more AI-driven, autonomous-driven networks. And having a platform or a workbench that can actually help you to sort of upload the data, train the data, test the data, evaluate different models, and then eventually be able to deploy these models at scale. So very important to have like a platform or a workbench where your data scientists can actually manage the whole process under a single view. And among the other challenges that we have seen, scarcity of computes or even integration or standardization to be able to like work through different data sources, different integration points, and again, like talent density of data scientists, and even just the sheer quality of ML models. And that's what I was mentioning in the beginning, that at Rakuten, we do have our mobile network in Japan, where we are actually qualifying, certifying these models, and then making them available on Symphony. So that brings me to our AI product offerings that we have at Symphony. We do have standalone AI APIs and products. Like you can see here, we have developed an anomaly detection engine, energy-saving algorithms that even Madhu and Patrick just mentioned about. We are actually working, and you would have seen the announcement this morning with OpenAI and some of the modern LLMs in order to integrate them and fine-tune them with telco flavors. But at the same time, all the products are also available embedded into our OSS portfolio, whereby we have different apps to manage the planning, operations, build out business processes, and even automation around the network. And at the same time, for telcos who want to innovate on their own, we do have a platform whereby employees or data scientists can come discover, train, test the models, and even evaluate and deploy them and perform the ML operations. So that is all in all what our approach has been towards AI. So with this context, now let me move towards our journey of implementation when it comes to this pragmatic approach to autonomous networks. So it all started in 2020 when we were building our network in Japan, whereby we even published a paper back then about how or what could possibly be the approach to actually realize the autonomous networks. And it was pretty straightforward in the sense that we identified that the whole autonomous network implementation can be framed into a generalized problem, which is basically consisting of 4 elements: sensing, analyzing, decision-making, and action orchestration. And once you break down this problem into these 4 fundamental categories, it becomes the next step is simply to start autonomizing each and every step one by one. And that's what we have been doing. So let me go to the first part of the control loop, sensing. So what we are doing is, instead of having this rule-based approach to monitor the data and KPI, we are actually implementing some of the autonomous monitoring algorithms, like anomaly detection as an example. And as you can see here, we have this implemented across our network KPIs, and the idea is to even calculate the anomaly score, the health score of a given metric using ML instead of having this rule-based formula for calculating network indices or KPIs. So that is the first step of the problem on how we are autonomizing the sensing or monitoring of our network. And as I said, one by one, if we start autonomizing all these aspects of this control loop, eventually you will end up with something that you can actually connect the whole, the entire loop, which can actually result into like an autonomous network whereby the AI is actually giving you recommendation of next best action or some of the suggested actions that you could take. And eventually, once it has enough confidence, it can simply start taking those actions with enough data and enough history. So the second aspect of this control loop is the analysis part of it. So again, as you can see here, we have created some modules within our product suite to actually perform the root cause analysis around the sensing or the monitoring that we are doing. As you can see here, a lot of KPIs, a lot of data. So we perform some auto correlations, we perform some auto RCA in order to actually make sense out of what we are monitoring and giving an analysis or an RCA around the same. Now, this is the most difficult part of the entire loop, decision, or to basically decide what to do or to decide the next best action. So here is where the real challenge comes in, honestly. So what we have done is that instead of defining these rules on paper or in theory, or like simply asking your engineers that, okay, what all are the actions you are taking? What we have done is we have actually created a framework to digitalize all the controllers in the network. So any action or any command or any troubleshooting action or restoration action that engineer is taking in the network, we have sort of provided them a framework to digitalize them in form of a catalog of actions or templates. And once the engineers start executing the network actions using these templates, it creates a framework for us to actually start monitoring who is doing what. So now we have the data, we can sense and monitor the data, we have the RCA, and we have the action as I was describing through this framework to practically implement any specific command or any specific restoration action through our framework. So that's how the decision-making framework works, in a sense that AI is constantly monitoring that, okay, what all are my metrics that I'm measuring and what all are the actions that the users are taking. And this way, instead of going around and asking people or basically forming these connections on paper, we are actually monitoring the data to identify what could be the next best possible action. And that way we are able to create this decision trees around that, what is the action that would make sense for a given scenario, let's say. So that has been our framework in order to understand the decision-making aspect. And I think once with enough confidence and enough data points, the system is actually able to recommend what could be the best possible next action. And then eventually with enough time, it will start executing the next action as well. So that has been our framework or an approach to start autonomizing each and every step in this control loop. And eventually what we can do is basically implement the whole loop in an autonomous way. So with this idea or with this context, let me just go to some of the use cases that we have been targeting, including some Gen AI use cases. And here I have categorized these use cases into level 3, level 4, level 5. And I think eventually we want to reach at level 5. We are not yet there 100%, but we have been taking some steps in that area already. So it all starts with simple use cases around doing the acceptance processes, doing the anomaly detection, going from dashboarding to insights, or from information to insights and energy savings. And that's what we already achieved as of last year. Now, the next set of actions or the use cases are on the level 4, which we are targeting this year, mainly around how can we use more AI and machine learning to do the log analytics, to drive the next best action and RCA automatically, use AI to implement some of the coverage and capacity algorithms, and in the end, use AI to do the process mining of network and business processes. So these are some of the key areas of key focus areas for us on the level 4 side. And now just going to the level 5 AI, which is again a topic of interest, and we have taken some steps in order to actually start using Gen AI, is mainly to assist our NOC engineers to actually write the automations using AI. And in my view, that is the single best use case of Gen AI in telecom, where you can actually convert your NOC engineers into automation engineers without a lot of knowledge on software programming. So that has been a key focus area when it comes to LLMs. Similarly, how can we use AI to drive incidents? So let's say there is an incident going on in the network, and usually there is an incident commander or an incident manager who is, usually taking some decisions on what is going on, who should be the next person on the call, stuff like that. How can we use AI to play that role of incident commander during a network incident. So that has been, again, a key research area for us. Similarly, how can we use more AI to plan the network investments instead of having network investments done through some of the network-specific domain or KPIs, or instead of using, pure resource monitoring or resource-based metrics to do the network planning? How can we introduce more AI, more customer centricity into the network planning? So that is one key area. And lastly, how can we have the intent awareness in the decisions or the questions that we are asking to AI? So that is, again, a key area of research that we have been conducting on level 5. So I think all in all, between these use cases, what we have done is we have sort of created a quadrant view whereby we are measuring the simplicity of implementation and benefit of these use cases, and we have divided them into these categories that you can see. The key focus, as I said, remains on the Gen AI. How can we use more of Gen AI to write more of automations? But at the same time, how can we solve some of the day-to-day issues around using more machine learning and AI to identify the correlation patterns, to do the config audits, instead of doing the audits based on, let's say, baseline or golden configs? How can we use more machine learning in that? Anomaly detection, identifying priority of an alarm or an incident using AI instead of, some of the rule-based or available severities from the vendors. So these are some of the areas I would say that we are prioritizing on the ops side. Similarly, on the planning of the network, how can we do a better process mining to identify the gaps or the improvement areas in a given network process? How can we have a smarter field force management using some of the LLM-assisted insights in terms of harvesting and reusing of the assets, in terms of recommending who could be the best turf vendor or a subcontractor for a given project? Or how can we even autofill some of the tasks or the workflows that users are filling manually every day? And similarly, on the planning aspect of it, we are actually using some of the drone-based, image recognition-based survey mechanisms to do our site surveys. How can we have site-level AI-based scoring instead of, having a manual rule-based network or KPI indices? And the last one, as I mentioned before, how can we have more AI-driven network investment planning? So these are some of the key areas that we have sort of prioritized towards implementation based on these metrics.
In a world driven by connectivity.
Yeah, so I think that's it from the talk perspective. Any questions? Would be happy to answer.
Do we have any questions in the audience for Anshul, Bhatt? Actually, Anshul, I have one question for you, and as it happens. How do you advise telcos to begin, let's say, operationalizing AI from the network to core to edge? How do they sort of approach that in different phases across different aspects of their infrastructure?
So I would say, it all starts with having the right data strategy. So unless you have your data in one place, or unless you are able to make sense out of your data, your metadata, unless your data scientists are able to actually search through these data points and, be able to understand what are the relationships, there won't be a next step. So basically, if you look at today, in most of the operator, it takes around 7 to 9 months to actually launch an ML model into production. So how can we reduce this cycle to a week? So I think it all starts with the right data strategy. And if you are able to have the right data strategy in the sense that having things in one place, having the right metadata dictionary defined, then I think it will reduce significant amount of time in terms of actually time to production or time to value for any of these ML models. So the right first step would be data strategy. And then it depends. I think in Rakuten, we started off with RAN domain because that's where the most of the spread in terms of quantity and efficiency was, considering the high number of count in terms of network elements. So we prioritized with RAN and transport network. But again, it depends on the priorities that the operator might have. But I would recommend to start off with the RAN and transport domain and then go towards core and other domains, which are relatively static compared to RAN and growing transport networks. So
Great. Thank you very much, Anshul. Are there any further questions from the audience? Give a big hand, ladies and gents, to Anshul Bhatt, the Chief Product Officer of Rakuten Symphony OSS.